Good. Now, let's look at notes number 9. If you don't have a copy of notes number 9, come and get it from the front. Notes 9 is labeled IC voltage regulators. And what does IC stand for? Integrated circuit. So if you go to page 4, go to page 4. Bottom of page 4. Figure 2 on page 4. We see a complicated circuit that is made up of a zener on the left, lots and lots of transistors, lots and lots of resistors, lots and lots of capacitors, okay? And you pack them all onto a small silicon substrate, and you form what's called a voltage regulator chip. Just like the AND gate chip and the OR gate chip that you're working with. Another chip like that is one that looks like the picture on page 4, and this one happens to be a 7805. How many leads are coming out? 3 leads. There's an in, there's an out, and there's a ground. Okay? And what this chip will do is this. It's real black magic. Okay? All that complicated circuit will result in a constant flat DC voltage that will result. Anytime I need a constant DC voltage, what I do is that is fully regulated. Meaning, what does regulated mean? If my input fluctuates a little bit, doesn't matter. The output is going to stay constant. If my output fluctuates a little bit, whether it's a motor connected at the output or something, a solenoid or whatever, if the load on the motor is fluctuating, still the output will be constant. If the temperature is going up and down, the output will be constant. And that's what this complicated circuit will do. Okay? And so what we're going to do is take this circuit and insert right here. Insert right here. Okay? So this is my load. So what I'll do, we'll draw this, but I'm just showing you what we're going to do. If I put one of these IC chips that has 3 pins, 3 leads, in, out, and ground, like this, okay? What's going to happen is that doesn't matter, or what it will result is a constant output. So, let's go back to page 1. Let's go back to page 1 and draw one of these circuits, as the example 1 says. Draw a circuit diagram showing a 7805 IC voltage regulator circuit connected to a full wave 2-diode rectifier circuit. So let's draw that. Full wave 2-diode rectifier circuit. How do we do that? I do a transformer. And then 2 diodes. Where do I connect the 2 diodes? At the top and at the bottom. And when I ask you on the test or on homework, in homework to label all these things, what do I mean by labeling them? I mean putting a D1 and a D2. Putting a T1 or a transformer. Putting a primary and a secondary. These are the kind of labels that will identify what that circuit is all about. an electrical circuit, an electronic circuit, a digital circuit is useless if you do not label the circuit. Okay, so then what do? I connect these two guys together like this. I bring out a center tap like this. I go from the middle here, or I can go from the top here, and I connect a capacitor, a big capacitor. Let's put a 1,000 microfarad capacitor. Okay? What this will do is it will produce, I start out here as an AC voltage, and with the help of this big capacitor, I will end up with what? A nice flat DC voltage. And this is at here, and I'll call this V DC average. Okay? And I know all the calculations of how to do this. I've done it many times. You had a question like that on the test. Okay? Given the primary voltage, turns ratio, then you identify the output voltage rectified, and then you do the VDC average calculation. So you know how to do that. You end up with a DC voltage here.